So, good afternoon, ladies and gentlemen. Here in Silicon Valley at 11th Cloud Expo. Good morning, good afternoon, good evening if you're following this next general session out there on the World Wide Web via SYS-CON TV and the 2.5 million pages it's embedded into. Duke Skarda is up next, one of our favorite speakers, SoftLayer's CTO, building a mainstream private cloud. He's got to explain to me what those quote marks mean. Take it away. Wake them up. Make sure they're vital, because they could be sleepy after lunch, Duke.
Thank you, Jeremy. I always, squeaky spot. I always look forward to this event. And usually we take advantage of this event. We leverage this, a good crowd and a great event to announce some new product that we've been developing. And that's always fun for me because we spend a lot of time putting those together. Last year we talked about RightScale. Earlier this year, we announced a partnership with Shannon, actually, who just spoke from CloudStack. And so usually that's what we do. Today, though, I want to take a little different approach, and I want to talk about a misconception that I see over and over again. We're going to close it by talking about private clouds and how you can deploy them and how to really take advantage of them. But there's a misconception that I get a lot when I talk to vendors, when I talk to existing customers and potential customers, which I do a whole bunch of. I spend probably 25% of my week talking to either partners, analysts, and customers. And this misconception that comes about often is that there is sort of one very strict definition of cloud. And that definition typically includes a hypervisor-based multi-tenant server, and anything outside of that very strict hourly consumed definition, people don't think of as cloud. On the opposite end of the extreme, there's an assumption that just about anything can be cloud. Everything is CloudWatch these days. And so there's a confusion on both ends of that. The misconception I want to deal with today, though, is the one that really narrowly defines what cloud is, because it misses the point about how you can derive value from leveraging this great new technology and all of the technologies that it comes with. So that's what I want to talk about. What I want to do is take a step back in the time machine, though, and look at how we as consumers consume products and consume change, because cloud computing is a massive change in the way that we as IT deploy gear. So we're going to go way back in time. I don't know, there may be people here who never had to use this device, but this was one of the coolest devices ever back in, what was it, like 2002 maybe, something like that. We got two-way pagers in the mid-90s, and that was cool, but we mostly used that for news. It was too expensive to text much. Our bosses didn't let us do much with it. But this device was great, right? It was like a little computer in your hands, and it had this really cool feature. Do you guys remember pinning, when you could pin each other with the original RIM devices? It was like the original sort of text. It was instantaneous. It was even more instant than texting today. Proprietary technology to RIM. But you could sit in a room and pin someone, send something to their pin, and it got there, and by the time you hit enter, it was already over there. So it was really quick. But this brought about this really horrible behavioral change in meetings. Two things came about from this. The first is that you would sit in a meeting and you would read your email. And the second is that if you weren't doing that, you were pinning your opinion about the speaker to someone else in the meeting. And so it just went back and forth, and meetings devolved into everybody sitting down looking at their device. And I remember, somewhere 18 months into owning these things, sitting in a meeting of 20, 30 people, when we were bringing two companies together, very important meeting. We were talking about acquisitions and how we were going to bring our platforms together. Extremely strategic, important stuff. And I looked around the room at one point. I looked up from my BlackBerry, and no one in the room was paying attention at all to the discussion going on. 29 of 30 people were looking down, and there was one poor guy at the head of the table talking. And I bring that about to say we had this really interesting technology, and we kind of deviated from our behaviors, what we had come to know and love, and we leveraged this technology in a way it wasn't really meant to. And it took 18, 24 months before we sort of pulled ourselves out of that. And I don't know if you guys remember, a couple of years after these came out, we started having meeting rules, right? No BlackBerries, and you'd put them face down and you'd turn them off as you come in the room. Not all meetings did that, but eventually over the next couple of years, we sort of settled into a rhythm. In a meeting now, I'll certainly have my iPhone on the table and I'll look at it, but I don't look at it incessantly like I did early on. Some people still do. Most of us have evolved to understanding how we can use this technology. Our behavior's changed. Another example, all 4 of these devices are in my bag right now. And I put this example up because I bet it probably applies to 70% of you. You've got some combination of these 4 devices in your bag. And the interesting thing about these is I don't know why I own all 4 of them. I like them all, but the amount of overlap between all of them is huge, right? If I'm going to read a book, which one of those would I grab? You'd think I'd grab the Kindle, but half the time I don't. Sometimes I'll grab the iPad. Sometimes I'll just use my iPhone. If I'm sitting at a coffee shop, I might even use my Kindle on my Air, right? If I'm going to answer email, it would seem that the Air is the right place to go, but the iPhone is probably what I use most, and sometimes I use the iPad. So I don't know why I have all 4. I suspect that over the next couple of years, I'll get rid of one of these, or maybe 2 of them merge into one. And it's the same for all of us. We all have tons of devices, and over time, our behaviors will adapt themselves to all these new technologies. So we get these technologies, they change what we do and how we do it. We're not real sure how for a while. It takes a couple of years for it to sink in. And the more profound the new technology, the longer it takes for us to figure it out. So I'm going to go further back in the time machine, and we'll look at the microwave. The microwave oven, and I wasn't alive when the microwave was invented. I'm not that old, but I do remember when they became really popular, when they ceased to be the thing for rich people and we all sort of had them. And I remember when I was a kid in the 70s, thinking, gosh, in the future, we'll cook everything in the microwave. And I remember seeing pictures of futuristic kitchens that only had a microwave. There was no stove, there was no oven. And we all know that's certainly not the case, right? We had this cool thing, and we thought we were going to do everything with that new tool. But it turns out that food cooked in the microwave just isn't as good as food cooked on the stove. You warm up bread in a microwave, it gets spongy and rubbery, right? It's not as good as if you warm it up in the oven. You can warm up your coffee in the microwave, but for some reason it's not as good as when I make it in a teapot and put it into a French press, right? So even though it's more efficient, it's quicker, I still like the other technologies that have been around since the dawn of time to make my coffee or my tea or my toast. They're better at doing that job. So even though there is great promise in the microwave, and it's still in my kitchen, we all have one, but it didn't overtake everything else. It took its place as a tool in the kitchen doing a certain set of jobs. I couldn't define for you the use cases for the microwave, but I know them and you know them, and they're a little bit different for each of us, but it's mostly for warming things up or cooking popcorn, right? There's some combination like that. That's what we use a microwave for. Great tool, though. Let's go one more step back. This is going kind of more macro. And this is sort of described in this book by Nicholas Carr called The Big Switch. Came out, I don't know, maybe 15 years ago, somewhere in that range. And if you haven't read it, it's worth the time. It's not a long read. But this book describes the change back in the 1800s of the electrical production industry. Originally, if you go way, way back, before any of us were born, mid-1800s, any power plant that existed was owned by the company that used it. It was all very localized production, right? And that stemmed from the fact that it started as a waterfall, and so you had to be located by the waterfall. And so the power production was right next to the plant. And that evolved over time into electronics and the electrical industry. And so every company that needed electrical power had electrical power engineers. They had people to manage that. They had to build it themselves. The same expertise existed in company after company after company, and it was very expensive. Somewhere in the 1800s, late 1800s, Edison and a couple other guys came up with the idea of centralizing the power production. And we know today that this is absolutely the way it's evolved. All of us use centralized power today. In fact, we use power. Probably today these lights are powered from some power plant in Minnesota or somewhere, right? Someplace completely different. We can send power vast distances now. So very, very centralized power production. But that didn't happen overnight, right? This kind of massive change in technology took decades and decades for the companies at the time to figure out how to leverage it and how to use it. They had they had debates, and it took a long time for standards to emerge about what voltages you were going to have and what wattage that would be and what frequency it would be delivered at. Things as fundamental as whether it was going to be AC or DC took decades to resolve. They eventually got resolved, and we all know, like I say, we use power today that's produced somewhere. And yet 100 years in, there are still new technologies, new things that come to bear in the power industry that change everything and change our understanding of things. I know intuitively when I'm in a room at my house if I need a 60-watt light bulb for a lamp. But you go to the store now and you don't really buy a 60-watt incandescent light bulb. You can, but that's, that 50-cent light bulb is off to the side. Now what you're looking at are LEDs, and you're looking at CFLs, and they don't say 60 watts on them. They say equivalent to, and it's really 10 watts, or maybe it's 15, and it has some lifespan that lasts, decades, but it costs $10 instead of 50 cents. And then there's the CFL that doesn't last as long, but it doesn't, different colors, right? It's very confusing all of a sudden just to buy a simple light bulb, something that's been around for a long, long time. So why am I talking about all this when I'm here to talk about cloud? And the point is, cloud is a very new technology. It's still maturing. The tools are maturing as we speak. I think they've reached a good maturity point. I'm going to talk about that in a minute. I don't think, we're a fledgling industry, but it's still new. The usage patterns that you guys are leveraging the cloud for are still nascent. You're still inventing what you're going to do with them. Cloud's only been around, 5 years, maybe 6 years, depending on how you want to define it, and we'll look at some definitions in a moment. But it hasn't been around that long. Maybe it's been around for 12 years, right? I don't know, but pretty recent. And so we're still, as an industry, learning what to do with it. So my main message is don't settle in yet. Don't assume that the leader in cloud, whatever cloud thing you're thinking of, whether it's Salesforce.com or Amazon or whatever vendor it is, don't assume that that's the only way to do that type of cloud. We still have a long way to go in a lot of ways that we're going to mature. In the 80s, 90s, even through 2000s, this is what our palette looked like, right? To change metaphors on you. If you wanted to make a painting, you were starting from scratch. You wanted to deploy a compute platform for your enterprise, you were starting from selecting a hardware vendor, selecting an operating system, building the data center, picking the networking gear. You had to put it all together yourself. It was hard, it was complex, it took a lot of time. The palette looked kind of like this. So I do think cloud has evolved, even though it's still young, still nascent. I think we've evolved, and we now have a palette that looks something like this. We have a very broad palette of tools, in fact. And that's why I don't want you to settle in on just one. Because with these tools, you can make really great new things. You don't just have to make paintings one way. You can start a new company, and the next day, you can be in business. You can have your application deployed across the globe. That's something you couldn't do 15 years ago. No matter how much money you were able to throw at it, you just couldn't do it. And now you can do that, by purchasing for dollars an hour a bunch of compute nodes. So it's very cool the time we live in. We're all familiar with great sort of instant start stories like Facebook and LinkedIn. All of the iPhones that we have tons of really cool apps on them that are invented one day, deployed the next, have your data stored centrally somewhere the next, and 4 days later they're beginning to add additional value to your life, whether it's Sobney and being able to take your contacts and sort them for you, or Path.com just able to show your picture to your close group of friends. You can do really, really, really cool things with the cloud. But it's difficult with that huge variety of tools to know exactly how to leverage all of these things. Especially, like I say, there's this weird dichotomy that there's this huge variety of tools, but people tend to think of one or two tools when they think of the cloud. And so that dichotomy is confusing to people. The reference model of a hypervisor-based server doesn't appeal to a lot of people, but when you think that's the only way to get there, you tend to either dismiss it or, decide you've got to change everything to live in a multi-tenant world. And that's not the case. So how do you live with these? How do you deal with all these tools? How do you leverage these maturing tools? So we're going to talk about 4 things. These are the things that I tend to talk about with these customers or vendors or analysts when I meet with them about ways that we talk to our customers about how to really leverage the cloud. 4 things you got to know. And we'll go through them in order. How to get value from the cloud. That's really about knowing what the cloud is and having a, to solve a problem, you have to be able to state it clearly. That's kind of what we're going to talk about in getting value from the cloud. Knowing your workload, what are you trying to accomplish and what kind of tools can you bring to bear on that? And then finally, how do you bring all of that stuff together? We'll talk about one specific example. So how do you get value from the cloud? The first thing you need to know is what is the cloud? And so there's no, you look in the dictionary, cloud is a thing in the sky, right? There's not one specific definition of this, and that's part of the confusion, is it can mean a lot of different things. So I'm going to look at, we're going to look at 2 examples of sort of official definitions. This is, I guess probably the most official. This comes from a governmental agency, National Institute of Standards. And they say that cloud is a technology that has 5 essential characteristics. It's on demand, meaning you can get it really, really quickly. You don't have to spend months preparing for it. Exactly how on demand? 30 seconds, 10 minutes, 2 hours, 2 days, 2 months. Doesn't say, just on demand. So there's some, subjective term there. I'd say, somewhere within a couple of minutes to a couple of days feels kind of on demand. I would say probably less than a day. More than that, it begins to not feel quite as on demand, but it's a little bit nebulous. Network access. This means you can get to it over the network. You don't have to be standing in front of it. Typically, it's referring to the internet. Resource pooling. This is where you get a lot of people gummed up. Exactly what resource needs to be pooled? In a colo environment, you're pooling your power with a bunch of other customers. Does that make it cloud? I don't know if it hits these other 5 elements, it might be cloud. Typically not rapidly elastic, though. So colo is probably not a cloud type product, but it meets some of these definitions. So if colo is not, and you're pooling power, exactly what degree do you have to be resource pooling for it to account? Does it go all the way down to the machine? Do you have to be pooling the compute environment itself? Somewhere in between those 2 feels like the right answer probably. So we'll just say things need to be pooled. The point is you're in a data center that you don't own. You don't have your guys rolling out with a screwdriver to maintain the gear. You're pooling a lot of that stuff with a bunch of other customers. And then there's varying degrees, which is this community model at the bottom. Private, community, and public deployment models. So private cloud is where you're a single-tenant cloud. Again, it's resource pooled, it's on demand, it's network accessible, it's measured, it's rapidly elastic, but it's private. You're the only one in it. At the public cloud, there's a lot of people in it. So the gradient there is going to be in really primarily the resource pooling. Which things are you pooling with whom? And to the extent you pool them with others like you, you're in a community. Maybe a bunch of universities get together and share a cloud. So that's what NIST says. And then they've got these service models, which we're not going to talk about, software, platform, and infrastructure. We're really focusing in on infrastructure here. The other one that I want to look at is Gartner. And this completely agrees with NIST, it just says it a different way. Gartner defines cloud as a style of computing. I like that, starting to get a little bit tighter, even though it's still nebulous, but it feels kind of nice. It's a style, it's a way of computing in which scalable, elastic, right? We saw those words in the previous one. IT-enabled capabilities, so compute, storage, are delivered as a service, measured. You pay for what you use. You don't have to buy a bunch of stuff for years to come that you may or may not use, using internet technology. So it's, again, over the network. So I think those agree. It's just a different way of saying it. One of them probably feels better to you, makes a little more sense. I like this line at the bottom, just kind of where it's going. This is a quote from Lydia Leong. She's the senior cloud analyst at Gartner. And she talks about this line between public and private clouds as blurring. And that going forward, it's all about an infrastructure fabric that allows you as a customer, you as a consumer, to select what things you're pooling and with whom. So kind of give a little bit more of the controls back to you. So that's what NIST says, that's what Gartner says. So if we kind of interpret from that, one thing it's not just a marketing term. While it is a marketing term, it's not just a marketing term. People can put cloud on anything that's out there. I'm not picking on Panasonic, but here's an example of a cloud phone. It's just a wireless phone, but it's got the word cloud on it. It probably doesn't meet any of those things that we just walked through, but they're using it as a marketing term. If you go through CES this coming year, cloud's going to be on everything from refrigerators to microwaves to phones to to everything, right? So, but it's not just a marketing term. Don't dismiss it as just a bunch of BS from the marketing department. There is a real sea change here. It's also not, and this is the most important point for me in this section, it's not a reference architecture. Nowhere in those two definitions did it say, and cloud is about having X or Y hypervisor deployed in Z environment. It talked about how it operates, right? These are all great tools. Shannon just talked about Cloud Stack. Great tool. These are all great tools. We deploy all of these in one form or another at SoftLayer. So I'm not talking against these tools, but they in and of themselves don't define a cloud. They're just tools in a cloud. There's not a single reference architecture for what the cloud is. So the way we like to think of the cloud is as an operations model. A way to interpret all of that and ingest it is just to think of it as an improved operations model. It's where you as a consumer can quickly get seemingly infinite compute capacity when you need it. You don't pay for the stuff you don't use. You don't have to do a bunch of planning. It's just there when you need it. That's an operations model. That's a way to consume a product that used to take a lot of money and a lot of time for you to be able to use. And now you can log in and in a matter of minutes to a couple hours, you can have a huge amount of compute and storage capacity at your fingertips. So that's what cloud is. So it's an operations model that has capacity on demand, consumption-based pricing, self-service. You don't have to talk to anyone if you don't want to, but you can. And it's accessible over the internet via some kind of API. So your computers, your software, your programs can manage it themselves if they want, or you can do it through a control panel. That's how we view cloud as an operations model. So first way to think about the cloud and how to get real value from the cloud is to look at it as an ops model. Don't think of it as a cheaper way to do something. It might well be and probably is, but that's not the real value. The real value is in you being able to make your operations easier and focus your efforts on all the stuff above the hardware stack. That's where your business is. Your business isn't about deploying gear. It's about doing something with the gear. So cloud lets you do that. It's a new and improved operations model. The second thing I want to talk about is your workload. To pick the right type of cloud compute, you need to know what you're doing. What's your workload? And I think of a couple of verses here. Public versus private, you need to kind of decide that. On-premise versus off-premise. You need to come to grips if you're an enterprise and you have on-premise gear, or if you're not, but you might need to because of security or regulations or some other reason that you've come up with. And then there's an enterprise versus web-centric workload usage pattern that I think is really important and can help you answer these other two verses. So if we hone in on that for a moment, the usage patterns I'm talking about, we sort of break the world into two primary use cases. There's enterprise applications, which by their nature are predictable. You know who's going to use it or what's going to use the app. It's your employees, it's your defined customer base, it is your network that's going to talk to something. You know you can scope the problem. You can bound the problem. You know what the users are. You know when they're going to use the system. You're going to use it between 8 and 5 Central Time. They're going to wake up at 2 in the morning and run a big batch. You kind of know what's going to happen. And typically associated with an enterprise app is it's a cost model, right? You're usually not making profit off of your enterprise application. In this world, you can predict a year, maybe 2 or 3 years out. And you're good to sign contracts. You're good to buy the gear yourself. You've done the business case. You know you're going to go do it. You know kind of the bounds of that problem. An internet application, on the other hand, is very different. It has global potential. You're not sure where your users may come from. They may be in the US, maybe in Asia, maybe it's an application that gets a ton of traction in Australia. You don't really know. You've got a global potential. And the same thing with your users. You don't know when they're going to use the thing. Maybe it's people that are going to wake up at 2 in the morning, your time. Maybe they're going to wake up at 10 a.m. your time or 7 p.m. They can use it any time of day, and the growth curve can be exponential. right? In fact, usually that's what you're hoping for in an internet app. But at the same time, you're hoping to make money off of this thing. So you don't want to buy a bunch of gear up front and then have this thing fail. So in the internet app, you want to be able to take some more risk. You want to be able to take your time letting the thing grow, but then your infrastructure needs to grow with it. So these are two distinct use cases. The other way to think about your workload is what constraints do you have? Is your application particularly sensitive to network latency or network failures? Do you have robustness of the compute requirements, or is it okay if your compute node disappears every now and then because of some unknown reason? There are plenty of parts of our applications can deal with failure, but not all part of our apps can deal with failure. So you need to know what you're trying to deploy and what your robustness requirements are. What's your duration of work? Is this something that's going to last for a couple of hours, a couple of weeks, or a couple of months? Because that defines what sort of term you might be willing to sign with a cloud provider. Data locality, does your data need to be on the box, or does it need to be centralized somewhere in the world? And what are your bottlenecks? Do you have specific bottlenecks, or do you have custom needs for your hardware? So knowing your type of workload, it's about, are you an enterprise or an internet application? What are you deploying? And you can be an enterprise deploying an internet app, right? That's not a customer base, that's a use case for the problem you're solving. And then what needs do you have? Do you have custom needs, or are you good with just a commodity, whatever they give you box? Third thing is to know the tools at your disposal. So there seems to be, and this is the core of my frustration and this misconception, there seems to be a new wisdom, accepted wisdom, that you shouldn't really care, that you should abstract yourself from your compute platform, that all you need to know is how many cores you need and how much memory. And then maybe something about your disk. If you need it to be good, you're willing to pay a lot more for it. And that is something that I would say is a single tool. It's a great tool. We have a product much like that. But it's not the only tool. So I would say reject the idea that there's one way of leveraging cloud, and picking the right tool always matters. So what tools do you have, and why does it matter? I'll use this as an example of what I'm talking about, where it's not just about the cores and the memory, it's about the architecture of the system. An Oracle RAC cluster has been around for years, decades, and has over time been honed to run in a really vertically scaled box. Maybe you get two. In a crazy scenario, you might have 3 boxes, but usually you got one giant box running. In a RAC cluster, maybe you get 2. And they like their storage off board. That's how they're built. They run really, really well in that environment. You go with a new technology like a MongoDB, and it's the opposite. It wants horizontally scaled environment. It wants a couple of cores of CPUs and running in a lot of boxes with a lot of local memory and local disk. It wants local fast disk. Those are two very different deployment architectures, and you want to know which of these you're trying to put out there. And these are just 2 databases, right? If you're designing your web tier or some kind of video processing unit, or something that's shrinking images, or whatever it is your application's doing, you want to know what kind of gear you need and be able to map that to the kind of gear that you're buying. Not always does one tool solve the problem. So there's 3 kinds of compute models out there. Public cloud, we're going to talk about these: public cloud, bare metal, and private cloud. If you think of the world in those 3, compute world in those 3 terms, you're okay. So public cloud is the multi-tenant environment. It's designed really for instant scale out. And in return, you get minimal controls over the environment. You can tell it cores and memory, and where it lands is, kind of up to the service provider. It's inexpensive to start out. You can get really small nodes because we're chopping up that server into small parts, so it's inexpensive for you to start out. But if you're going to run a lot of loads for a long time and they're big, might not be the most cost-effective way to go. Again, this is about instant scale out. Great for webheads, great for short duration workloads, great for testing something, doing development work, great for small stuff. Then there is a bare metal cloud. Bare metal is a single tenant world, so it's a box dedicated to you, built to your specifications, how many cores, which CPU, how much you want it to cost. If you don't really need the latest and greatest, it might be less expensive. If you want the latest and greatest, it's going to cost you more. And you have full control over this environment. You typically get root access. You're the only one on that box. You can do whatever you need to with it. Great for databases and app tiers that have specific bottlenecks and needs where you need to architect around them. Really good for long-running workloads because these are typically sold by the month. You can get them by the hour, but the best price here is to get them by the month. And so really good for longer workloads. And then the third option here, private cloud. This is what Shannon was just talking about if you were here for the previous talk. It's about infinite VMs with no additional cost. You set up your hosts, and then you have management of the VMs within them. So you can scale really well within those hosts until you need more hosts. But you get the benefit of virtualizing, not me, the service provider. You take a little bit more management on, but in return, you get cost savings. This is a great way to wring additional savings out of a hosted environment. But you can, like the bare metal, you can build it to your specs, and it's a secure single-tenant environment. One misconception about a private cloud is people tend to think of it as on-premise, meaning it's deployed at the customer site or in the customer's colo space. They don't really think of a private cloud as something you can deploy into a public space. And I'll show you how you can do that in a moment. So typically it's believed that this is only good for enterprise apps, and it's not really good for internet scale. And I'll show you how you can solve both of those. So tools at your disposal, public, bare metal, private. And finally, let's talk about how you can bring all this stuff together. So a question that comes up, like I just mentioned, this misconception is that you can't get internet scale out of a private cloud. They feel incompatible because typically people think of a private cloud as an on-premise cloud that you've purchased all the gear for. And how do you get internet scale when you're deploying into your private cloud? And we'll talk about one product from us. I'm not going to talk about a bunch of products from SoftLayer, but the way we have addressed this is we have this product called Private Clouds, which is based on Cloud Stack from Citrix. And in this world, it's a single-tenant environment with multiple hosts. You name the hosts, you pick the data centers. We still don't have a contract on it. It's still monthly fees, only month-to-month contract. Configurable hardware options. It's available in a couple of hours, so you get that instantly available feeling. And growth, you can elastically scale it from within our portal, and then your cloud just kind of grows. Let me show you how that can work. You can start, as I say, you can pick your hardware. So you can pick everything from a small host, small set of hosts, to very large hosts. On the small end, maybe a dual proc environment with quad cores, so you get 8 cores per box. Or you can get up to a quad processor, 10-core Westmere with multi-threaded servers. You got 80 cores effectively on that box, and you can stick up to ½ a terabyte of memory in there. So you go everything from very small and inexpensive to really big and robust. You can pick the storage architecture. You can pick the line speed, so you're really able to define your box. You can deploy multiple zones in multiple data centers, all controlled from the same Cloud Stack UI. You deploy all of that through our control panel, and you do that on a month-to-month basis, and we turn them all up in just a couple of hours. So go through a real quick example. Maybe you start with an initial deployment of 1 zone, 2 guest hosts using local storage and our object storage to store your images. So you kind of get started, you test it out, you like it, and you decide you're going to use this for development. You got a dev team in Asia somewhere. So now you want to grow. You go into our portal, you order another node in Dallas, and you order 4 nodes for the dev team over in Singapore. We deploy all of that, set up all the networking. In 2 hours, you have your private cloud has just expanded international boundaries, and you're ready to roll in a couple hours. When you're ready to go to production, you decide you're going to take your Mongo databases, pull them out of that environment, or your Hadoop cluster, I've gotten this example, pull them out of that environment, stick them on custom bare metal gear so that you can pull them out of the VMs. You don't want Cloud Stack sort of interfering with that management at all. So you deploy those into a bare metal cloud. So now you've combined your private cloud with a bare metal cloud. And when you go to full production, maybe you put your web heads, put them across all the United States and Dallas and Singapore and San Jose, use our public cloud for that. And now you're using the public cloud, your private cloud, and a bare metal cloud, all to solve your production architecture through one control panel on a month-to-month basis. You've now brought internet scale to a private cloud. And that is the last thing that I wanted to talk about. So if you, just to reiterate, know how to get value from the cloud, think about it as an operations model, not a reference architecture. know your workload so that you can pick the architecture you need, know the tools, public cloud, bare metal cloud, and private cloud, and then find a provider that can bring whichever combination of that you need, can bring it to bear for you in the type of economic model that you want to buy it in. Thanks. You can find more on our website, of course, and we have a gigantic booth right at the entrance to the hallway over here. In fact, I think you have to cross through it just to get into the hall. So look forward to talking to you.
Thank you so much. Duke Skarda, CTO of SoftLayer, as he says, you can't miss him. Thank you, sir. We are then going to